All right, so in this video, I'm going to start to demonstrate how to solve problems involving normal distributions. All right, so as noted in a preceding example, studies on automobile safety suggest that stopping distances follow an approximately normal distribution. For one model of car traveling at 62 miles per hour, the mean stopping distance is mu equals 155 feet, with a standard deviation of sigma equals 3 feet. Danielle is driving one of these cars at 62 miles per hour when she spots a wreck 160 feet in front of her and needs to make an emergency stop. About what percent of cars of this model, when going 62 miles per hour, would be able to make an emergency stop in less than 160 feet? Okay. Is Danielle likely to stop safely? All right, so the first step in our strategy is to always draw a picture. So because we're told the shape of the distribution, we're going to go ahead and sketch a normal curve. Okay, so 1, 2, 3, 4, 5, 6, 7. All right, there we go. All right, and we know the mean. So the center is 155 feet, right? So, a typical car, average car would stop around that distance. And the standard deviation is 3 feet. So we're gonna go by increments of 3. So 158, 161, 164, 152, 149, and 146. Okay, and then let's go ahead and label this stopping distance with units of feet. All right, so the question is, what percent of cars will be able to stop in less than 160 feet? Okay. All right, so let's figure out where 160 is. Let's use screen. Okay, so here's 158 and here's 161. So 160, okay, would be almost 2 standard deviations away, but not quite 2 standard deviations away. And we're trying to figure out the percent of cars that can stop in less than 160 feet. So we're going to go ahead and shade the left side of this distribution. All right, so at this point, we need to start doing calculations because the empirical rule is not going to apply here. Empirical rule only works if we're at exactly 1, 2, or 3 standard deviations. Okay, so we're going to calculate the z-score next. All right, let's do it right here. Okay, so the z-score is our data value minus the mean divided by the standard deviation. Okay, now check this out. I said that 160 is almost 2 standard deviations above the mean. Okay, so when we do the calculation, right, we're going to have 160 minus the mean, 155, divided by the standard deviation, 3. Okay, so that's 5/3, which is 1, we'll round to 1.67. Okay. So typically with z-scores, we will round 2 decimal places. All right, cool. So now we have a z-score. Next, we need to take this z-score and convert it into a percentile. All right, so what I would do here, we have 2 options. You can go to table A, or you can use your calculator. I'll show you both. Okay. So we're going to look up 1.6. Right, in the first column of the table, and then the last digit is 7, so that would show up as 0.07 on the top. Okay, and we'll see where that row and column intersect. So here's my table. So there's 1.6, here's the 7, and so I'm getting 95.25. So 0.9525. Right, so that's a proportion. Proportions are between 0 and 1, but you can always just convert it to a percentage, just move the decimal 2 places. All right, so what we found is 95.25% of cars going at that speed and of that model should be able to stop in 160 feet or less. All right, so how would you do this on a calculator? So you're going to press second and then the vars button. Let me show you that. Okay. So second vars takes you to the distribution menu. And then the command we're going to use is normal CDF. Okay. All right. We need to give it a lower bound. Okay. So since we're shading everything to the left, you're going to just choose a really big negative number. Most people just choose like -1,000. Okay. The upper bound is where you're shading stop, so it's the right endpoint, so 160. Oh no, what am I doing? What am I doing? We're looking up the z-score. Okay. So we're gonna put 1.67, sorry, as the upper bound. Okay, the mean is 0, standard deviation is 1. Okay, and then you get 9525. Okay, so it matches here. Okay. So what confused me was I was looking at the normal distribution with the original units, but what I wanted to do was think about a normal distribution with standardized units. Okay. So we can draw that as well. You don't have to do this for every problem, but this is what I should have been thinking about. Okay. So once we standardize, right, we're going to have a normal distribution that's no longer measured in feet, but is measured in standard units. Okay, so the mean would be 0, and the standard deviation would be 1. Okay, and then our z-score is 1.67, which would show up right about here. And then we're still trying to find the same area. Okay. So these two areas are really equivalent. They're going to be equal, right? The area less than 160 feet is equivalent to the area less than a z-score of 1.67.